Hello everyone, welcome to Neelam tutorial, and in today's video we'll be dealing regarding some of the very important reactions of phenol. So in phenol you might have seen Colles reaction as a repeated question being asked. Next you might have seen Remer-Tammin reactions, coupling reaction, preparation of phenolphthalein, one of the indicator that we use in lab. This phenolphthalein is an indicator. So how do we prepare phenolphthalein using phenol? It's also a basic question that is being asked. Next, how do we prepare picric acid from phenol? That's also the next question. Next, we have preparation of phenol by Dawes process and what will happen when phenol is treated with zinc. So these are some of the very common question which is being asked from your class 12 phenol chapter. Let me deal the entire of them. If you will have any queries, do comment in the comment section. I'll be making another video to reply you back that one. So what exactly is Colles reaction? So in Colles reaction, when sodium phenoxide is treated with CO2. So this is your carbon dioxide. Carbon dioxide. So when sodium phenoxide, sometimes what happened is phenol has been given. So at the time, what you need to remember is the phenol need to be treated with Na so that it will convert into sodium phenoxide, ONA. Okay, and then you can continue the reaction. So phenol being treated with Na or NaOH, and then it converts into sodium phenoxide, further treated with CO2. Now what will happen is, in CO2, we have C double bond O. So right over here, if the bond breaks, the O will have negative charge and the C will have delta positive charge. In the entire corner, there are hydrogen. What will happen is this hydrogen will move right at this point. This will shift over here, and the sodium comes and attaches to this oxygen. So the thing something happen like this, that at this point it becomes phenol. It changes into this group phenol. And over here, this carbon goes and attaches right at this point to form C double bond O, O and A, which is an intermediate. Further, it is being treated with dilute HCl to form the Na is being replaced by H and it forms salicylic acid. So basically the final product of Colles reaction is salicylic acid. What will happen? So you need to remember when sodium phenoxide is treated with the CO2 in the presence at a temperature of 125 to 127 degrees C, 4 to 7 atm pressure, it makes an intermediate which further reacted with HCl to give salicylic acid. So sometimes the question comes, what is the final product of Colles reaction? You must be able to reply it is salicylic acid. Next, sometimes the question comes, what are the reagent or what are the reactants used for Colles reaction? So you must be able to say sodium phenoxide and CO2, which is further treated with dilute HCl. Okay, let's move on for the second most important reaction, that is your Remer-Tammin reaction. What exactly is Remer-Tammin? You might find this question, it's must repeated. Remer-Tammin reaction. Remer, Remer-Tammin reaction. So what is Remer-Tammin reaction? In this reaction, when phenol is being treated with CHCl3. So what is CHCl3? You might be known about this. CHCl3 is your chloroform. So when phenol is treated with chloroform in the presence of NaOH, what will happen exactly right over here? At a temperature range of 60 to 65 degrees C, what will happen is this Na will be taking away one of the chlorine right from here. What you might be knowing is over here, there we have a hydrogen being attached. So what will exactly happen? The hydrogen will be removed and this carbon will move and attach right at this point. So what will exactly form over here is, and one of the Na, we have two Na over here. So one of the Na replaces this hydrogen and it comes right over here. And the another Na takes away the Cl. So one NaCl is being liberated and uh, another we have H2O being replaced, and they gives out the product something like this is formed. Sorry, intermediate. Here we have ONA, and here there is an attachment of CHCl2. Okay, so this is an intermediate we generally get. This intermediate is further being treated with two molecules of NaOH. Okay. So what will happen is again this 2Na group will be taking away this 2 chlorine, and the 2 hydroxyl part, OH minus part, will move and attach to this carbon. And this 2Na will be taken away by the 2 chlorine, and there will be the removal of 2 molecules of NaCl. And what will happen is the further, sorry, there we have, it will look something like this. Here we have ONA. Here we have CH, and instead of 2Cl, now we have 2OH group being attached with it. Now what will happen further is, further in this reaction, one of this hydroxyl group and the other hydrogen group will be removed as water, and the bond will break and it will shift right over here to make double bond. So this will look something like this, and here it will be ONA. Here it will be C double bond OH. Further, this is being treated with dilute HCl, and what will happen is this Na will be replaced by H, and here will be OH, and here we'll have CHO group, and this is what we call salicylaldehyde. So this is what you need to remember. When phenol is being treated with, sorry, when phenol is being treated with, so here what we have, when phenol is being treated with a chloroform and NaOH at a temperature of 60 to 65 degrees C, we get an intermediate something like this. Next, again, it is being treated with NaOH, and there will be the removal of 2Cl, and here we will have 2OH group. Further, there will be the removal of one H2O molecule, and this will transform into an aldehyde group, which is further being treated with HCl to form salicylaldehyde. So it's a multi-step reaction, but you need to do it in certain steps. Okay, next we have action with benzene diazonium chloride. Action with benzene diazonium chloride. So what will happen when phenol is being treated with benzene diazonium chloride? So this reaction is also known as coupling reaction. Coupling reaction. So what do you know, need to know right in this one is when phenol is being treated with benzene diazonium chloride. So what is benzene diazonium chloride? So you'll have a benzene molecule and there is a diazo group N2 and there is Cl. Okay. Which is further being treated with a phenolic group. Okay. So what is phenol? There will be OH and here will be Cl. So now what will happen is this is further being treated with in basic medium actually at a temperature range of 0 to 5 degree C. Sorry, here you will have a H group. So this is your phenol and this is benzene diazonium chloride. So what will exactly happen is the H group from here and the Cl group from here will be liberated at HCl. And this 2 group reactant will together join to form a new type of product that is something like this. N2, and here you'll have OH group. So along with the liberation of HCl. So this is what we have para hydroxy azobenzene. So this is what we have para hydroxy azobenzene or azodine. Okay. So this one we have benzene diazonium chloride being treated with the phenol at a temperature range of 0 to 5 degrees C, and we get para-hydroxy azobenzene or azodine, and this reaction is known as coupling reaction, or it's also a red dye. We can call it. It is red in color, so basically it is red dye. So next we have action with phthalic anhydride. Action with phthalic anhydride. So what will happen when phenol is being treated with phthalic anhydride? So what exactly is this? Let me go for it. So just draw a benzene. Sometimes students get confused in this. And then you will have two carbonyl group being attached with it. There will be the attachment of two carbonyl group, and these carbonyl groups are again being attached with the oxygen. So this is what we call phthalic anhydride, and it is being treated with the phenol. So how am I going to write the phenol? Let me make show you. So here we have two molecules of phenol. So what is phenol? C6H6, generally benzene. If one of the hydrogen is being replaced by OH, this is what we call phenol. Okay. So you might be very clear right at this point. Obviously, we have a hydrogen. In entire of the corner, we have a hydrogen. So over here, so we have a hydrogen. What will exactly happen is this O will be taking away this two hydrogen group in order to liberate water. So this basically takes place in the presence of conc H2SO4 because it's a dehydrating agent, and we need to heat it out. What will form there? The reaction will look something like this. Sorry, the product will look something like this. The benzene will remain as it is. This carbonyl group will remain as it is. This carbonyl will not have double bonded oxygen. Now it is being connected with a two order phenolic group. Instead of double bond O, there will be two phenolic group being added with it. And this is the structure of your phenolphthalein. Phenol, phenolphthalein indicator. Okay, so this is how we prepare indicator, that is it. So how do we need to prepare this? So when phthalic anhydride is being treated with phenol, okay, we get phenolphthalein indicator, and it's being treated with the conc H2SO4 and heat. Let's move further. Next we have what will happen when phenol is being treated with zinc. Action with action with zinc dust. So when phenol is being treated with zinc dust, okay, it will undergo distillation and heat. So what will happen is the bond will break right from this point and it will simply make benzene. Okay. Other than that, there will be the liberation of ZnO. So this is the zinc is the only metal which can replace. Zinc is the only metal right over here with which if you will treat, the phenol will convert into benzene. If you need to convert phenol into benzene, if you want to convert phenol to benzene, so what you need to do? You need to treat it with zinc dust. So that is the only way to convert phenol into benzene. Okay. Next we have preparation of chlorobenzene by Dawes process. Preparation of chlorobenzene by Dawes process. The very first one we have over here. So if we have chlorobenzene, okay, it's being treated with NaOH at a temperature of 350 degrees C and 300 atm pressure. What will happen is basically this H will be taking away this Cl and this group will come and attach right at this point to form ONa, that is sodium phenoxide. Sodium sodium phenoxide, which is further being treated with HCl. Okay, so that this Na will be removed and there will be the attachment of the H group in order to make it phenol. Sorry, I made a mistake here. Preparation of phenol by Dawes process. Over here, so what exactly happened? It forms phenol. So this is the way how we can prepare from chlorobenzene being treated with NaOH. It gets transformed into sodium phenoxide, which is further being treated with HCl to make phenol. Okay, so this is a way for the preparation of phenol by Dawes process. So these are some of the most important reactions from phenol. Okay, now we have over here some important react questions right there. So here we have a question. What product would you obtain when phenol is treated with phthalic anhydride? So I think you can do that. Phenol with phthalic anhydride gives you phenolphthalein. I already have done the question. Starting from phenol, how would you obtain parahydroxyazobenzene? So that's your coupling reaction. The one which I did in coupling reaction, you need to do the same one because the product of coupling reaction is parahydroxyazobenzene. So you need to do coupling reaction for this. Next, we have what is the laboratory test of phenol? So you need to do a laboratory test for phenol. Next, what happens when phenol is treated with zinc dust? So it get converted into uh, okay, I missed picric acid. How is picric acid prepared? So I'll just explain you this one. Just wait a minute. Next, you have starting from phenol. How would you prepare methoxybenzene? So methoxybenzene is will be dealing about all those questions in the next video, or was it in the same? We have a Riemann reaction, coupling reaction, and some questions right over here. So kindly try them if you can solve it.